Okay, continuing with the topic Unit 1 Univariate data, we look at how data are represented. Stem plots, histogram, bar charts, dot plots are all ways of representing the data. And with stem plots and histograms, we will describe the shapes of the... And in describing the shapes, we'll try and figure out whether it is positively or negatively skewed, as we will see later. Okay, now we look at stem and leaf plots. And stem and leaf plots, or simply called stem plots, is just one way of ordering and displaying data. And the good thing about this, it keeps all the raw data intact. Below is a stem and leaf plot, and it shows the stem on the left and the leaf on the right. And this is how the data is arranged: 1 and 14, 2, 22, 23, 23, 24, etc. And the key to this is a 3/5, which basically means 35 years old. So in this example, we're looking at ages of people. Okay, so let's try and look at what the data looks like. As you can see, each data point in green is represented in the stem and leaf plot. For example, if we look at the last number of 65, in green is shown as 65 in the stem and leaf plot as the last entry. Also very important to note that on the leaf side, the numbers are going consecutive, going up in order. So this is what is referred to as an ordered stem and leaf plot. So it's very good to order it because we can use the data to work out other information like the median, mean, mode, etc. Okay, now we look at the dot plot, and the dot plot is used for displaying discrete or categorical data. So with an example, we'll look at how the dot plot is used to plot discrete data. And in this example, we're looking at 7 students, amount of time they spent on the iPads per day, the number of hours. Okay, so we got 1 4 3 3 3 2 2, and in a dot plot we basically show these number of hours per day in the form of dots, and each dot represents the one student. So there should be a total of 7 dots in our dot plot. A histogram is another way of displaying large data sets and organizing data. Right? The data, firstly, if you got a lot of data, you can organize it using a frequency table, and then from the frequency table a histogram can be drawn. Okay, let's look at the following example and try and draw a histogram from this. Remember, first you have to draw a frequency table. From the frequency table we can draw the histogram. Now looking at the tally table, let's look at row 2, for example, the 2 dash. That means we're looking at all the weights that's in the range from 2 to 3, and there's a total of 5. So our tally table shows 4, and with the line across it which stands for the 5th one, and our frequency is 5. So that means there's 4 weights in the range from 2 to 3. Actually, I meant to say that there is 5 weights in the range 2 to 3, frequency of 5. Now we need to translate or transfer this data from the frequency table into a histogram. And here we have our frequency histogram, and you can see it is a graph for continuous data. And let's have a look at the histogram. The first 2 columns there from 1 to 2 represents a frequency of 2. That's straight out of my frequency table on the left, and from 2 to 3 it represents a value of 5, which is straight out of the frequency table as well. Okay, now this is a bar chart. If you look at the supermarket shoppers, number of times at the supermarket, for example, 1 time at the supermarket, the frequency was 8. This is just basically an example telling you what a bar chart is about, and as you can see, it is of equal width and it's separated by small equal spaces. Okay, slightly related to the bar chart is a segmented bar chart. Now this is made up of a single bar which represents all of the data. So if you look at the length of the bar, this will represent 100% of the data, and there's different fractions of this complete length of bar which represent different percentages of whatever data is represented. So as an example, let's look at this. Okay, here you can see segmented bar charts. There's many bar charts attached to the one graph, but as you can see, every single bar totals 100%, and every shaded region there, you got a blue, red, green, and a purple, I think it is, represent different parts for the total production cost. Okay, the raw material cost for 2013 is roughly about 20%, and then 20 is probably about 30% for the direct labor, etc. Okay, so that's how a segmented bar chart works. It's also called a stacked bar chart. A log scale graph is another very useful way of representing data. So if drawing a histogram, sometimes the data can have some very big variation in the data points, and it's important to try and use another system, another scale, and the log scale is a very good way of reducing this variation in the data. So I will show you two examples of a graph without being log scaled and one being log scaled, and you can look at the data and look at how much better the log scale graph looks and how it reduces the variation. Okay, the first graph is the histogram. It's a conventional histogram without being log scale. You can see the huge variation in the data. It's actually not even a histogram. You can't even get the columns or the bars to actually touch. And now notice what happens when we plot the log data. As you can see, it's a much better graph, much better looking graph, and it is a histogram where the bars are actually touching each other. So it's a much better way of representing the data. Okay, this is now coming to the end of this screencast video. I need for you to complete the assignment questions from the prescribed text. So this would be chapters 1.2 to 1.4. Okay, so 1, 2, 1, 3, 1, 4, complete all the assigned questions. Thank you.